In this video, I'm going to have 3 problems for all of you guys to solve, but these are specifically kinematics in one dimension. So you only need to worry about one dimension. You don't have to worry about going left or 70 degrees up. Throw a pebble 70 degrees up in the air. You don't have to worry about any of that. We're only doing kinematics in one dimension. I will have a video for kinematics in 2 dimensions. But let's go start off with the problem. You drop a piano off the side of a cliff 14 meters high to try to hit Bugs Bunny. What is the speed of the piano when it hit Bugs Bunny? There should be a question mark there, but don't worry about that. So, how do you approach this problem? Well, all objects, no matter how much they weigh, they'll fall at the same speed. So we just need to worry about the acceleration of gravity in this case. So we can already think about gravity since we're dropping something off a cliff. Gravity, we can mark down our information here. Gravity is negative 9.8 meters per second squared. So we're definitely going to include direction here. The height you dropped, well, technically, since you're going down 14 meters, your height or your change in position is negative 14 meters. And your initial velocity, your initial y velocity is just it's just 0 meters per second since you're just dropping it. But here's the thing, quick side note, these x values can be interchangeable with y. So if you ever see x, it can be interchangeable with other variables. You can actually, when you do 2 dimensions with kinematics, you can solve for each dimension individually. If that helps with the little sidetrack there, though. But let's go back to this problem. So we have gravity, we have height, and we have initial velocity. Well, gravity is some form of acceleration, right? It's some form of acceleration. We have height, and we have initial velocity. Which kinematic do we use? Take a guess. We're trying to solve for the final speed of the piano when it hits Bugs Bunny. Take a guess. Which kinematic do you use? Well, if you guessed this guy right here, you are absolutely correct because we are trying to solve for the the final velocity. We're trying to solve for the final velocity. We have initial velocity, we have acceleration, and we have delta y in this case instead of delta x as the formula states. So we only have one missing variable, final velocity. So let's solve for that. So we have final velocity squared is equal to initial velocity plus 2a delta y in this case. If we plug in all our values, we get final velocity squared plus, well, initial velocity is just 0, so this is 0 squared. Our acceleration is negative 9.8, so the negative matters here. I guess it doesn't really matter that much since we're calculating speed. But, okay. And your delta y is negative 14 meters. So if you solve for VF here, so if you just multiply everything here and then square root it, you end up getting 16.565 meters per second. And if it told you to solve for the velocity, you would write negative 16.565 meters per second. We're solving for speed, so we're only worrying about the magnitude of our vector. But if you worried about your velocity, then the direction would be going down, so the velocity would be negative in this case. So right here, your piano when it hits Bugs Bunny is negative 16.565. In this next problem, you have a bug. It's a very fast bug because it can travel 2,000 meters in 6.7 seconds. So, I don't know, maybe it's like what's the fastest bug? Maybe the bugs that hit your windshield when you're driving. I got no idea, man. But this bug is just really fast, absurdly fast, but we can still solve for its acceleration. So it travels 2,000 meters. Delta x is equal to 2,000 meters. So let's write down all the information we have again. 2,000 meters. Delta t is equal to 6.7 seconds. And the acceleration is constant. which is perfect because in these kinematics you're assuming that the acceleration is constant. So we have this, and we starts at rest also, sorry. Initial velocity is 0 meters per second. So which kinematic do you use? Take a guess. Take a gander. If you guessed this first one, then you're right. And the reason why is because, well, this kinematic equation can be adjusted so that you only have to worry about delta x. So if you subtract x initial on both sides, you get delta x on the left side of the equation. So if you were to adjust everything, you get initial velocity times time plus 1/2 acceleration times time squared. And what we have delta x here. We have time, and we also have our initial velocity. So these are all good. These are all good. Check marks, check marks, check marks. But the only variable we're missing is acceleration. So given this formula, we can actually solve for the acceleration by just isolating it. So let's go ahead and isolate that. So we have delta x is equal to initial velocity time plus 1/2 acceleration time squared. So initial velocity is just 0, so this zeroes out, and you can rewrite your equation like so. So delta x is equal to 1/2 acceleration time squared. And if you multiply by 2 on both sides, you get delta 2 times delta x is equal to acceleration time squared. And if you just divide by time squared on both sides, you get 2 times delta x times squared is equal to acceleration. So if you solve for your acceleration here, you would get, so I'm going to write that in my calculator, 2 times 2,000 divided by 6.7 squared. You would get an absurdly fast acceleration of 89.107 meters per second squared. This is absolutely insane. I don't think maybe a Tesla can go this fast. Who knows? But we have the acceleration, but now we need to find the final speed. Well, final speed is easy. Final speed is just, well, if you use this kinematic here, so if you use final speed is equal to initial velocity plus acceleration times time. Well, we have initial velocity, we have acceleration now, and we also have time. So if you just finish out this equation, well, initial velocity is 0, so we can ignore it. We finish out this equation, you just get 89.107 times time, 6.7. So your final velocity will be 597.01 meters per second. Your mom is flying up, carrying your Xbox at 7 meters per second upwards. Who knows why she's doing that? Maybe you were playing too much Minecraft during COVID and she wanted to destroy your Xbox because you need to do your homework. But she accidentally drops it at 78 meters high, which is for sure going to destroy the Xbox. But what we're concerned about isn't the quality of the Xbox, and if you can play Minecraft on it after, it's the speed of the Xbox when it hits the ground. So let's solve for that. So we can write down your initial velocity. So we're going to worry about the y-axis here. So I'm going to write initial y velocity is 7 meters per second because she's flying up at 7 meters per second. And your change in height is also, so change in, or I can just write down h, is equal to 78 meters. Okay? Well, since we're talking about the y-axis and we're on Earth, usually in these problems you're going to be on Earth, gravity is negative 9.8 meters per second squared. And what else do we need? We do not need anything else. So how do you solve for the final velocity? Go ahead, pick your kinematic equation. Think about which one would be the good one to use, and maybe you don't have to solve for multiple things. Okay, you know what? I'll just stop talking. Go ahead, pick it. So I'm gonna start. I'm gonna tell you the answer. Well, if you pick this one, you're wrong. It's actually this one. This guy right here. So okay, if anyone picked this one, I didn't mean to insult you, but it's most definitely not even close to the right one. But this guy right here on the top right, that's the right one. And the reason why is because we're trying to solve for the final velocity as it hits the ground, as the Xbox slams into the floor. And right now, well, if you look at all your variables that you have, well, you have initial velocity. You have the acceleration given here. You also have your change in height, which is delta x in this case. But you can it's interchangeable with delta y. Matter of fact, the height is actually, the change in y is actually negative 7.8. So let's write down negative 7.8. 78, not negative 7.8. Oh my goodness. Okay, so let's go ahead and use that equation. Final velocity squared is equal to initial velocity plus 2 times acceleration of delta y, or h. So if we plug in all our values, you get, so initial velocity is 7. So 7 squared times 2 times negative 9.8. That matters. Keep the negative in there. And also, your height is negative 78. So your delta y is negative 78. So if you solve for everything here, plug it into a calculator, you get your final velocity as 39.72. 39.72 meters per second. And that for sure is going to destroy your Xbox and bye-bye Minecraft. So unless if you're an 11-year-old kid, you probably won't. You're probably not playing with the Xbox. No offense to the Xbox players, but let's propose a more conceptual idea in this case. What if she was flying downward at 7 meters per second? What would the final velocity be? What if she was flying downward? What if your initial velocity was actually negative 7 meters per second? Well, due to the equation here, if you just put negative 7 squared, your answer will be the exact same. And why? Why is that? Well, if you were to draw the graph here, let's draw the little diagram. What's happening? Maybe your mom is going straight up. Let's not worry about the x-axis. She's going straight up. Actually, she's going straight down. No, she's going straight up. Yeah. In this case, first case, she's going straight up at 7 meters per second, and then if she stops, it kind of arcs down. But at the same height here, at 78 meters, she drops it at the same time, 78 meters. These 2 points on both sides of the parabola will have the exact same velocity, or exact same speed, vertical speed, more specifically. So this is going to be traveling 7 meters per second up, and this is going to be traveling 7 meters per second, negative 7 meters per second down. This is a fun thing about physics. Your initial velocity when you launch at the same height will be your final velocity at the same height. So at 78 meters per second in this parabola, both will be 7 meters per second and negative 7 meters per second. And in this case, if your mom was flying downward at 7 meters per second and then she let go and it went to free fall, it would be the exact same scenario as you launching it 7 meters per second up, except for the time. The time will be different. It takes for the time will be different for the Xbox to crush into the floor. So that's it for the video. I just want to explain a quick concept there. Hopefully, if you understood it. But as always, if you have any questions, put it down in the comment section.